41. Does that say 2x minus 4 to the x?
Yeah.
That is tricky.
There's a, even though there's a property that explains it, I just don't remember that.
Let's think back to derivatives. We take the derivative with respect to x of a to the x. We got to remember what that equals. What was the derivative with respect to x of e to the x? Yeah, that's e to the x, right? It's really e to the x times 1 times the natural log of e. So when the base is an e, the derivative is that thing to the x times the natural log of it. Is it over?
Well, that's not e.
Well, let's say we're not sure. You could be right. Let's try it.
Well, I guess that would be it. You should take a derivative, but forget the answer to that one.
Well, yeah, this is derivative, right? But let's say we forgot about this too. Terry had a nice idea here. We said y equaled e to the x. Right? The way we get the x out of the exponent is to take the natural log of both sides. Then we get the natural log of e to the x by putting the x in front of x. Then when we take the derivative implicitly, right, with respect to x, the derivative of the natural log of y is 1 over y times dy dx. Then over here, natural log of b is 1, the derivative of x is 1, we just get 1. Cross multiply, we get dy dx equals y. Right? Y was e to the x, so that just equals e to the x. Which really is, we got that natural log of b, so it's times natural log. So that makes you think, okay, when you take the derivative, if it's a to the x times the natural log of a, we take the antiderivative. And first, Jocelyn once told me, if you got to do something, don't let something you're not sure about inhibit you from doing what you know. Right, Jocelyn?
Right.
Hey, Jocelyn, what's the antiderivative of 2x?
I can't let it be what I know.
What?
Can't
Josh, add 1 to the exponent, divide by the new exponent. What's the exponent on that x? What's 1 plus 1? So antiderivative of 2x would be 2x squared divided by 2. Right? Or just x squared. X squared. Now minus here, if the derivative of 4 to the x is 4 to the x times the natural log of 4, then I think the antiderivative would be 4 to the x divided by the natural log of 4. Plus some constant. Because the antiderivative, we do the opposite. Right? And then here the 2's will cancel, so we get x squared minus 4 to the x over natural log of 4. Plus some constant. Is that what they had? Basically?
Yeah, I think so. So
I had my shoelaces crossed. Right?
how is that the opposite? You explain it with the same rule,
Well,
but you see where you add 1 to the exponent and divide by the exponent?
Not when there's an x in the exponent. But if you think that antiderivative is the opposite of a derivative, same way as dividing is the opposite of multiplying, adding is the opposite of subtracting. Now, if we're not sure now, we can check this, right? The derivative of this should be equal to what? The original thing, right? So if we take the derivative of x squared, we get 2x. The derivative of 4 to the x is 4 to the x times the natural log of 4. That's over the natural log of 4. Derivative of constant 0. Those cancel, we get 2x minus 4. Whatever you take an antiderivative, you can check it. If you take the derivative, you should get the original thing. Well, Terry, look, we learned by doing the homework, we learned something valuable. The antiderivative of a number raised to the x is that number raised to the x divided by the natural log of that number. If we hadn't been doing the homework, we might not have gleaned that information. Let's see, 50.